we're going to look at a wee summary of what you need to know for National 5 vectors. Basically, vectors are a study of a direction and a magnitude. In other words, it's a journey from A to B. It's shown with an arrow and a line. So there's a vector there that's drawn, and there they're showing the direction that it's going in. Similarly, there's one there. Now, there is the definition and components of a vector. And what that means is you start at a point and you go 2 to the right and you go up 3. And from start to finish, you would draw your line for that one. There is a trapezium, and it shows you those 2 lines are vectors and those 2 lines are parallel. So we'll go through everything that you need to know. So we're starting off. This is from a checklist, and it says a vector is a quantity that has magnitude and direction. So it's got a size and it's got an arrow that tells you in what direction you're moving in. Vectors can be expressed as line segments with an arrow to indicate the direction. These can be named in either 2 ways, either using a lowercase bold letter, or you can use a letter that's underlined. So we can't really write in bold. So what we do is we write the vector down and we underline it. That vector there can be described as vector u, but it can also be described as vector AB with a wee arrow above it. That just means exactly the same thing. Now, we're going to look at some vectors here. It says express and directed line segments in component form. So component form is similar to your coordinates, but they're on their side. So you're starting here at this point here, and this vector is described as 4, 2. That means it goes along 1, 2, 3, 4 boxes, and it goes up 1, 2, and that's called the components of that vector. Now, important things about vectors. There's AB vectors get component 5, 2, but PQ's got a component 5, 2. So in other words, it goes along 1, 2, 3, 4, 5, and up 2. P to Q, I go along 5 and up 2. X to Y, it's just cut off the end there, you go along 5 and up 2. So all of those vectors are equal. They're all exactly the same. If I slid one across, they'd all fit on top of one another. So we can say vectors are equal if they've got the same length and they're going in the same direction. They don't necessarily have to start at the same point, because they're not all starting at the same point, but they're the same vectors. So we've got to think about how we name these vectors. So the top line tells us the direction that it's going in the x-axis. If it's going to the right, it's positive, and if it's going to the left, it's negative, similar to your coordinates. If it's positive at the bottom, it means it's going upwards, and if it's negative at the bottom, it means it's going downwards. So vector A starts at a point, so it's starting there, and it's described as minus 2, 3, so it's got to go 2 boxes to the left and 3 boxes up. Vector B is described as 3, negative 2, that's its components, are 3, negative 2. So there's my starting point. I go along 3 to the right, but it's negative 2, so I'll go down 2. Vector AB starts there, and it's got to go 4 boxes to the left, so 1, 2, 3, 4, and since it's negative 2, it goes down 2. So there's the vector A and B. So there's a wee summary of what those component numbers actually mean, but it's like coordinates on their side. So now we can be asked to work out a resultant vector, okay? And if you're asked to draw it, which doesn't happen often in Nat 5, but you've got to understand what they are. So if we want to find the resultant vector of u plus v, there's vector u there. So I start here, and vector u ends there. So when I'm adding on another vector, I'll start at that point, and then I'll put the vector v there. Now, what does that mean? It means that we've started at that point and we've gone to that point. So vector u plus v is the resultant vector, the wee orange one that's there. Now, if we look at them in terms of components, u vector goes across 1, 2, 3, 4, and it goes up 2. So it's 4, 2. V vector starts there and it goes 2 to the left and 2 down, so it's negative 2, negative 2. So if we want to find u plus v, so component terms, we've got u vector, which is 4, 2, we've got v vector, which is negative 2, negative 2. So the resultant vector of u plus v vector, and there should be a wee line under that, gives me, if I put in the components, U vector is 4, 2, V vector is negative 2, negative 2, add across the top, so 4 plus minus 2 is the same as 4 take away 2, giving me 2, and 2 plus negative 2 is the same as 2 take away 2 is 0. Now you can see that U V vector is 2 to the right, and it doesn't go up or down, and that's perfectly described in those components. You can sometimes be given components and asked to do various combinations of them. So there's vector A, which is 5, 1, and vector B, which is 6, negative 5. So A plus B is simply 5, 1 plus 6 minus 5. Add across the top gives you 11. Add across the bottom gives you negative 4. If you've got 2A and you want to take away 3B, you've got 2 lots of 5, 1, and you want to take away 3 lots of 6 minus 5. So we'll multiply by 2 to give us 10 and 2. We'll multiply this by 3 and leave the negative sign there. So 3 6s are 18, 3 5s are 15, but that was negative as well. So 10 take away 18 is negative 8. 2 take away negative 15 is the same as 2 plus 15 is 17. So it's straightforward combinations of them. So you can multiply a vector by any number, you can add them, and you can subtract them. A position vector is a vector that starts from the origin. So I could have position vector O to A and O to B. Now, I'll just read through this. It says in mathematics, a position vector is a vector from the origin to a point in the coordinate axis. Example, the position vector of the coordinates 2, 4 is 2, 4 on its side. There we can see it goes across 2 boxes and it goes up 4. You've got to learn this thing here. So we're on A to B vector. Now we can work that out because AB vector, you take the components of small b vector and you subtract A vector. And I've put this on another page because you've got to learn this. So AB vector is basically the coordinates of B turned on their side, take away the coordinates of A turned on their side. And when I say turned on their side, I mean we're changing them into components. So AB vector would become 4, 7, 9 minus A vector, which is 2, 5, and 7. And you just work that out. So 4 take away 2 is 2, 7 take away 5 is also 2, 9 take away 7 is also 2. So AB vector is 2, 2, and 2. Now that can work for any letter. PQ vector is small q minus p. Now sometimes you're asked to work out the magnitude, so you could be given something like the coordinates of M are say 2, 1, and 3. Coordinates of N are 5, negative 1, and 6. And you could be asked to find Mn vector like that. Now that's the magnitude. I'll remind you of that in a minute. But what you would do first of all is you'd work out Mn vector, which is small n minus m, and that would be 5 minus 1, 6, and I want to take away 2, 1, and 3. Now we've got 5 take away 2, which is 3. I've got minus 1 take away another minus 1, which is negative 2. 6 take away 3 is 3. Now, what do the 2 lines down the side of that mean? That means the magnitude, and I'll remind you of that later. We'll come back to this slide in a wee minute or two to find magnitude. Right, so here we've got the coordinates of 3 points, A, B, and C, and we want to find the following vectors. So we want to find AB vector. So AB vector is B minus A. Take the coordinates, turn them on their side, so that would be minus 5, 0. It's only in 2 dimensions in this question, but you can have 3 dimensions, it makes no difference. A vector is 3, negative 2. It would just mean we've got an extra line at the bottom for the Z. So minus 5 minus 3 is minus 8. Nothing take away negative 2 is the same as nothing plus 2, which is 2. Likewise, AC vector is C minus A, and that would be 11, 4. And I want to take away A vector, which is 3, negative 2. And I do that simple sum. 11 take away 3 gives me 8. And 4 take away negative 2 is the same as 4 plus 2, which is 6. Okay, that one you would just work out vector BC, and then you'd multiply all the components by 2. There's just 2 lots of them. Sometimes you've got to work out coordinates in 3 dimensions, and you've done them since primary school in 2 dimensions, x and y, but now we've got coordinates in x, y and z. So x and y are sitting on your table. You're going to the left and the right, and you're going up to the top and down to the bottom. But when we've got this third dimension, this z, it's coming out of the desk, it's coming up into the space in your room. So sometimes you can be asked coordinates. Here I've drawn down it's a cuboid, and it's sitting on the origin. There's the origin there. Origin in 3 dimensions, the point 0, 0, 0. None across on the x, none across on the y, none across on the z. Now, there we're told the dimensions of this cuboid, so it's a 3 by 2, and it goes up 1. So it's coming across 3, and then it's going back 2, and it's coming up 1. That's the size of that cuboid. Now, with all that information, we can work out the coordinates of all those points. So point A is there. So first of all, I'm not going to cross any in the x. I'm not going to cross that way. I'm staying there. I'm not going to cross any in the y. I'm not going in that direction, but I'm coming up z. So it's going to be none in the x, none in the y, but it's coming up 1 in the z-axis. B is over here. I'm starting at the origin. I don't need to go across the x-axis, so it's none across in the x. But I need to go back in the y-axis, and that is the same as that bit there. So I'm going back 2. But I'm also coming up in the z-axis. I'm coming up 1. So it's 0, 2, and 1. Point C. Point C is right up here. That's called the space diagonal, going right through the shape. So it's right up at that top bit. So we go along x, y, and z. So I'm going to go along 3. I'm going to go back 2. And I'm going to go up 1. So C is the point 3, 2, and 1. Now we're looking for point D. So D is sitting there at the front of this cuboid. So we need to go across 3 in the x-axis, but I'm not going back any in the y-axis. So it's going to be 3, 0. So 3 there, none in the y, but it comes up 1, so it's 3, 0, 1. E is the point down here. It's sitting on that x-axis. So I'm going 3 across in the x, but I'm not going across any in the y, and I'm not going up any. So it's got to be 3, 0, and 0. Point F. Point F is sitting down there at the bottom of the cuboid. So we have to find our path going across the x, y, and z. So we'll go across 3 on the x, we go 2 on the y, but we don't need to go up any. So it is 3, 2, and 0. Point G. Point G is sitting at the back of this cuboid. So we start at the x-axis. We don't go across any in the x, but we go along 2 in the y, and we don't need to go up and down. So it's going to be 0, 2, and 0. So sometimes you're asked coordinates in 3 dimensions. If you're asked coordinates in 3 dimensions, you're usually just asked 2 of them. Okay, we'll look at the first cuboid here, and we're looking for any clues. So this point up here, they've told me it's 15, 8, and 7. So it must be 15 across there. And in the y-axis, it must go 8, and it must go up 7. So I've put the dimensions in there. So we want the coordinates of point B. So point B goes across 15. It doesn't go any in the y-axis. It stays there, and it doesn't go up and down. So B is the point 15, 0, 0. F is the point that's back here. So on the x-axis, we've got to go along 15. And the y-axis, we're going back 8, but we're not going up and down. So it's going to be 15, 8, and 0. Then we want point C. So point C is up here. Point C, I'm going to go across 15. I'm not going along any in the y-axis. So it's going to be 15, 0. But I've got to go up 7. So it's 15, 0, and 7. G, is the point that's there. So we're given that one. So we were told that that was 15, 8 and 7. Don't need to do that one. And H is this point here. So I'm not going to cross any in the X, so it's 0. But I've got to go back 8 and I've got to go up 7. So it's 0, 8 and 7. Now point E, the last one there, is that one. It doesn't go across any in the X. It goes back 8 and it doesn't go up and down. So point E is 0, 8 and 0. And I've missed out point D. Where's point D? Point D is sitting there. So point D, I'm doing none in the X. I'm not doing any in the Y, but I've got to come up 7. So it's 0, 0, 7. Okay, the second one, we want to find the coordinates of the points that are not named here, but the full point E is 1 across, none back, and none up. So it's sitting on the x-axis, but it's 1 unit away from that axis there, the origin. Then they tell me this point is 10, 4 and 5. So that's going to cross to 10 there. I know it's going back, it's sitting on the axis there, so it's going back 4, and it's going up 5. So we'll use that information to help us find other coordinates. So coordinates of B first of all. So B, I'm starting at the origin. I've got to go across to 10. I'm not going any in the Y and I'm not going any in the Z. So it's a point 10, 0, 0. If I want point C, so we'll start our journey on the x-axis. We're going across 10. I'm not going back any in the y-axis, but I've got to go up 5. So it's 10, 0 and 5. Point D is this one here. So on the x-axis, I've got to go across 1. I'm not going any in the y-axis, but I've got to go up 5. So point D is 1, 0 and 5. We'll do one more point there. I'll do point H. So point H follow from the origin. So I'll go across 1. In the y-axis, I've got to go back 4. And in the z-axis, I'm going up 5. So it's 1, 4, and 5. Now this one's probably more tricky than you would be expected to do, but you could, however, get something like that. So we're looking for clues in this one. So I know that there's a square base at the bottom of this pyramid, as it tells me that those two bits are the same. So I know that right in the middle of this, right in the middle of that point up there is 23, 6 and 20. So that means in the z-axis, the height it's going up to is 20, so I know that. Now I need to work out some other things. Going from there to there in the y-axis, that's going 6. That's telling me that that's 6 along there. Okay, when it gets to that bit there is 6. Now that's only halfway across there, so BC, instead of being 6, BC has got to be 6 and another 6, so the total distance across that is 12. So that means the distance from there to there has also got to be 12 units. Okay, now if we know that that point there to the middle is 23, and halfway across that's got to be 6, then we can work out what point E is going to be. But what we'll do is just now, we'll get all our dimensions all sorted. So I know that going across there is 12, going back there has got to be 12. How do I know that again? Because halfway across it turned out to be 6, so it's got to be 6 and another 6 gives me 12. Now, if that there, going to that point there is the point 23, so I'll take that 12 out of there just now, that's the length of that shape. So going to that point there is the point 23 across in the x-axis. There it's there, I'm going 23 across, I'm going back 6, and I'm going up 20, and that takes me to point E. Now, if I know that that whole distance there has got to be 12, half of it has got to be 6, if I work backwards from 23 and take that 6 away from that, that means that that's got to be at 17, So 6 across to there. Now I want to go another 6 across to there. So 6 onto 23 takes me to 29. So that should be enough information for me to work out the coordinates of all these points. So we'll do A. So A is the point from the origin. I go across to 17 and the X. And the Y, I don't go any. I'm not going in or out. So that's 0. And I'm not going up or down. So it's 17, 0, 0. Point B and the x-axis, I've got to go right along to 29. I'm not going back any, so it's 0 on the y-axis, and I'm not going up any, so it's 0, 0. Point C will follow from the origin, so point C, I've got to go right the way along to the end of that, which is 29. The y-axis, I've got to go back 12, and I'm not going up or down, so the z-axis is 0. Last wee point there is point D. So for point D, I'm going to cross to 17. On the y-axis, I'm going back the same amount as that, so I'm going back 12. And going up and down the way, I'm not, so on the z-axis is 0. Just to recap that, how did we know all those numbers? So 23, 6, 20 tells me that that is going up to 20 as a height, the z-axis. I know that the y-axis, it went back 6, but that point was just halfway in the middle of that square-based pyramid. So it means half of that was 6, so the whole distance there has got to be 12. Now, that side is the same as that side. So I know that whole distance there has got to be 12, but they tell me that it's going to cross in the x-axis to 23. So I know that that bit's got to be 6 and that bit's got to be 6. So from the 23, take 6 away, takes me back to 17. From the 23, add 6 on, and it takes me to 29. And that's how you got all the coordinates. Now, that one is quite a tricky one, okay? So maybe try that one on your own as well. Next thing you've got to learn is the magnitude of a vector, and that's just the size of the vector, how big it is. And it's basically just like Pythagoras on its side. You've got to know what the symbol is for magnitude, and it's 2 parallel lines down the letter. So the magnitude of vector U is that. The magnitude of vector AB is that, and you've got to know that. And all you do is you take each component, you square them, and you take the square root. Doesn't matter if there's only 2 components or 3 components. So that must be learned. That's how you work out the magnitude of a vector, and it's dead easy. Once you know it, it's simple. Sometimes it can change into a surd as well, so we have to look out for that. Right, so last thing is vector pathways, and vector pathways are journeys. Okay, so it's a journey from a certain point to another point, and we'll look at some of them in a second. So I want to go back and look at this one for the magnitude. Okay, we left it earlier on, so we worked out mn vector, which is n minus m. We've got the components of it, and that was the components 3, negative 2, and 3. Now, I want to find the magnitude of that. So all you do is you take the square root of 3 squared, you add on, the next number is minus 2 squared, and the next number is 3 squared. If you've got a negative, you must put your bracket round about it, okay? And everything's been added, all those squares have been added. So that becomes the square root of 3 3s are 9, so that's 9. Negative 2 times negative 2 becomes plus 4, and 9 again, and that would give us the square root of 22. Now sometimes that changes into a surd, and when we go into some exam questions you'll see how that's asked. Okay, we'll go back onto a vector pathway. So vector pathways are just a description of a path from beginning to end of a vector. Vector pathways can be described either in terms of their components or by combinations of known vectors. So this wee diagram here, we've got S, we've got T, and we've got U. Now I know that that's vector A and that's vector B. So I can describe SU. So SU, if we've got to go along paths that we know, I can't go along that one because I don't know what that vector is, but I do know S to T, and then I do T to U. So SU is the same as ST vector plus TU vector. Now, when you've got a wee vector pathway like that, it starts where you want to begin and it gets to where you want to end. That's the two outside letters. These letters in the middle must link. They must be exactly the same. So, when you've got that, then we've just got A vector and then plus B vector. And it's as simple as that. Okay, now you will be given ones like that. Some of them are a wee bit harder, but we'll look at some of them in a few minutes. I'm going to go through the exam questions that have come up in the last few years and what you really need to know and what standards you need to know it to. So first exam question, it could be, these are essential skills. These questions are dead easy. It's just working out components. The important thing is if you're asked a resultant vector, it just means you add or subtract. So that one there is dead easy. 5 take away 3 is 2, and 2 take away 4 is -2. So they're simple, they're in 2 dimensions. We'll do this one down here that's in 3 dimensions. So we've got 2 lots of that vector. So 2 lots of that vector would give me 0, 2, and 16. And I want to take away 3 lots of that vector. 3 times -1 is -3, 3 times 2 is 6, and 3 times -5 is -15. So I'll multiply them first, and then do straight across the top, which would give me 3. The middle, the y components, gives me -4. And the z components would give me 31, because that's the same as 16 add on 15. We've now got component ones where you're asked to work out a resultant vector, but you're also asked the magnitude. And remember, the magnitude is the square root of the first number squared, second number squared, third number squared, and we all add them up. Right, so this first one we've got a plus b, so we'll do a plus b vector. And we'll work that out first. So A vector is 1, 3, -2. B vector is -1, 1, and 5. So the resultant vector there is 1, add -1 is 0. 3 add on 1 is 4. -2 add on 5 gives us 3. Now we want AB magnitude. So I want the magnitude of that vector there. So it's the square root of nothing squared plus 4 squared plus 3 squared. And when I work that out, I'm going to get 0 plus 16 plus 9. That gives me the square root of 25. I know the square root of 25 is equal to 5. And that's all you're asked to do there. Right, those other ones, you can do them if you want to do them as a wee bit of practice. But you do your B plus C and then follow that through for your magnitude. That one, you're doing A vector, take away B vector. Okay, so sometimes they're put into some sort of an application question. So a question where you've got to work backwards. So you're using the knowledge that you've got to find something else. So in question 1, it says the magnitude of that vector there is 21. Find the possible values of k. As soon as you're asked the magnitude of a vector, then work out that magnitude. So the magnitude is the square root of 4 squared plus, it's a letter, but it doesn't matter, you can still square it, plus k squared, and the last component is 20 squared. Now, I know the answer to that. I know the answer is 21, so I can fill that in. So we want to solve this, so we'll do as much as we can. Okay, so the first thing we'll do is we'll do the square root of 4 squared is 16, k squared can't do anything with, I'll write it in, and 20 squared is 2 2s are 4 and 2 zeros added on. I know the answer to that is 21. So the square root of 416 plus k squared is equal to 21. Now I can't deal with square roots. What's the opposite of a square root? It's the square. So if I square both sides here, then that square root disappears and I get 416 plus k squared, and that's equal to 21 squared. Now 21 squared I can work out, so 21 squared turns out to be an answer of 441. So I've got 416 plus k squared is equal to 21 squared is 441. I want k squared, so k squared is equal to, take that 416 away from both sides, and when I take 416 away from both sides, I end up with k squared is equal to 25. Now, that means k is equal to the square root of 25. But I know that 5 times 5 is 25. But I also know that negative 5 times negative 5 is also 25. So when you take a square root, you get a plus number and a minus number. And it's really written like that. Don't expect to write it like that at National 5, but you will, however, be expected to know that the square root of any number has got a positive value and a negative value. So k can either be equal to 5 or k can be equal to negative 5. Now sometimes in the question they'll say just the positive value, or k is greater than 0. Here it says find the possible values of k. So we want the negative 5 and the plus 5. Next one, it says A and B are the vectors with components 3, 5, negative 2 and 3, 5, 1. Find the magnitude of 3a minus 2b, leaving your answer as a surd in its simplest form. So we'll do that one. What we want to do here first of all is we want to work out 3a minus 2b. So it's going to be 3 lots of 3, 5, negative 2 minus 2 lots of b, and vector b is 3, 5 and 1. So we'll do 3 times that first one, gives us 3 3s are 9, 3 5s are 15, 3 times negative 2 is negative 6. And I'll leave the minus sign and I'll multiply that one by 2. 2 3s are 6, 2 5s are 10, 2 1s are 2. So when I work that out, I get 9 take away 6, which is 3. I get 15 take away 10, which is 5. I've got negative 6 take away another 2 is negative 8. So that is our 3a minus 2b. Now I want the magnitude of that vector. So I want the magnitude of this thing here. So it's basically the magnitude of the 3a minus 2b vector. And that means it's the magnitude of, and I'll just write the components inside there so we know what we're doing. And same rules, it's equal to the square root of 3 squared plus 5 squared plus, put it in a bracket because of negative sign, negative 8 all squared. Dead easy. 3 squared is 9, 5 squared is 25, and negative 8 times negative 8, 8 8s are 64, and it is going to be positive. So that gives us plus 64. When I add all of them up, that gives me the square root of, and it turns out to be 98. So we want to leave this as a surd in its simplest form, and this happens quite often, that these magnitude questions turn out to be surd questions. So we're thinking about our square numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. So I want to know which one of them divides into 98. And with practice, you'll start to get to know these. That one's going to be 49 times by 2. So break your root sign down the middle, which gives you the square root of 49 times the square root of 2. Square root of 49 we know, so it becomes 7 root 2. So that's a typical magnitude question in vectors. Another wee past paper question. It says the vectors p and q are shown in the diagram below. Find the resultant vectors p plus q. Express your answer in component form. Right, so there's vector p, it's starting there and it's going in that direction. So it's going to the left by 1, 2, 3, 4, 5. So p vector is going to be negative 5, put in the equal sign. And then it went up, so 1, 2, 3. So it's negative 5, 3. Q vector in component terms, find the start of it. It must be there because it's going in that direction. So it goes across 1, 2, 3, 4. So it's 4 to the right, so that's 4. But then it's going down 1, 2, 3, 4, 5. So what we want to do then is we want to find P plus Q, add the two of them together, and when I add them together I get minus 3 plus 4, which is minus 1, and I've got 3 plus minus 5, which is minus 2, and that gives us our vectors. Another SQA question, an easy one. Find the resultant vector of 3a plus b. So 3 lots of a 3a is going to be 9, 12 and negative 3. Just times all that by 3. And b vector is 5, 3 and 2. So 3a plus b gives me 9, 12 and negative 3. Add on b vector, which is 5, 3 and 2. Add the top numbers, gives me 14. Add the middle numbers, the y components, gives me 15. And add z components, which is minus 3 plus 2 is minus 1. So vector questions like that, they are a gift question. They're dead easy. Easy to do. Just learn all of the wee bits that you need to know. There's another one. Okay, and that was 2016, but a similar type of question. So this time we want the resultant vector of a half p plus q. So a half p vector, half of 4 is 2, half of negative 6 is negative 3. We want to add on q, which is negative 5, negative 1. So the resultant vector is 2 plus negative 5 is negative 3. Negative 3 plus negative 1 is negative 4. An easy 2 marks. Okay, another vectors question. There's a double line, so that means I've got to find the magnitude of 4u take away 2v. So 4u vector is going to be 4 3s are 12. 4 times negative 2 is negative 8. 4 times negative 1 is negative 4. I want to take away 2 lots of that one. So I'm taking away 2 2s are 4. 2 times negative 4 is negative 8. And 2 times 1 is 2. Take them away. 12 take away 4 is 8. 8 take away negative 8 is same as negative 8 plus 8, which is 0. And negative 4 minus 2 is negative 6. Now we want the magnitude. So the magnitude of that vector, 8, 0, negative 6. We just learn what it is. It's the square root of 8 squared plus 0 squared plus, in a bracket, negative 6 squared. And that gives me the square root of 64 plus 0 plus 36. That gives me the square root of 100, and the square root of 100 we know is 10. So these questions are dead easy. Okay, there's a few like that, and I'll just go through them, but I'm not going to do them all because they're all the same. That next one, find the resultant vector of 2u, so 2 lots of that, and take away one of them. Express your answer in component form. You don't even need to do magnitude for that one, so easy. That one there, you do have to find the magnitude of that vector. So the magnitude is the square root of 6 squared, plus minus 13 squared, plus 18 squared. Next one, it says 2 forces acting on a rocket are represented by u and v. There's u vector, there's v vector. Calculate the magnitude of u plus v and write it as an answer as a surd in its simplest form. So I'll do that one because it's bringing in the surds again. When you've got a surd to do, you're going to be extra mark. Right, so we want to find out u plus v vector. Okay, so u plus v vector is basically those two together, and all I'm going to do is just add them. Okay, and I'm taking a shortcut, I'm not rewriting it. So 2 plus 7 is 9, minus 5 plus 4 is minus 1, and minus 3 plus minus 1 is minus 4. So we want the magnitude of that vector. So u plus v magnitude is equal to the square root of 9 squared plus, in a bracket, minus 1 squared plus, in a bracket, minus 4 all squared. When you square, negative numbers will become positive, so you don't really need to worry about that, but you must put them in brackets like that. So 9 9s are 81, 1 squared minus 1 squared is 1, minus 4 squared is 16. I'm going to add all of them together, so that would give me 82, that would give me 92 plus another 6 is 98. That one we've come across before as well. The square number that divides into 98 is 49. So it's 49 times by 2. Break your root sign down the middle, and that gives you square root of 49 is 7 root 2. So when you're doing them, you'll start to see the same pattern of numbers. I'm going to finish this video here because it's quite a long video, but I'm going to do another one with another couple of questions on three-dimensional coordinates, and more importantly, vector journeys. I don't want to make the video too long, so we'll stop it at this point and I'll do a vectors too.